Hey guys, Steven here. Today we are recording a video and we are going to be solving Leetcode 304 range sum query 2D immutable. Given a 2D matrix, handle multiple queries of the following type. Calculate the sum of the elements of matrix inside the rectangle defined by its upper left corner and lower right corner. Implement the num matrix class. So it looks like we're getting a sum defined by the top left and bottom right of the rectangle, and we are initializing a class that basically anytime some region is called on this class, it returns the sum of the elements of matrix inside the rectangle defined by the upper corner and lower right corner. Okay, good. So this class just returns the sum region every call it gets of whatever rectangle the sum region function is called on. So, for example, brute force, we could just sum the values from the row, the top left to the bottom right, right? And we could do that by going for just a matrix traversal from for R in range row 1 to row 2, and then for C in range column 1, which starts right here, and then column 2, and we would just be iterating from top left to bottom right as you usually would with a matrix. However, that brute force is O of n squared worst case for every sum region call. That's really bad. So we can make it better. We can design an algorithm where we have O of 1 time complexity. And let's just remove all the dimensions for a second, right? Let's say we had 30142. If we did this problem on 30142, we would have to calculate the sum from this, and let's say we wanted to calculate the sum of 0 to 4. We would have to calculate, actually I have a drawing right here. We would have to calculate the sum like this. And then we would have to just keep brute forcing it, right? But what can we do? Well, we know about the idea of prefix sums, right? So we know we could get 0, 1, 4 in O of 1 time if we do the sum of 3 to 4 and subtract off the 3, and then we would have the sum of 0, 1 to 4, and that's just a subtraction operation, which is O of 1 time, right? So let's go back now and generalize this to 2D. So in 1D, we were able to get the last element and the sum up to there. So how can we think of the last element in our 2D, right? Well, for me, the last element would be the bottom right, right? It's the last element we're supposed to be processing. So let's fix the bottom right. And let's say we want to calculate this sum. Let's say we want to calculate this sum, 6320, right? Well, what was I saying before? If we know the sum from 0 up to 3, the top left corner of the entire matrix, if we already have this sum calculated, right, what can we do to get 6320? Well, if we have this sum, we need to subtract off this, and we need to subtract off this, right? But clearly we have some overlap with the top left, so we will add that back, right? So if you see what I'm saying, we subtract off the top of the region that is rooted at the bottom right, and we subtract off the left to the region that's rooted by our bottom right. And then that'll give us the region from top left to bottom right. And we subtract the above and the left from the entire region rooted at the bottom right. That'll give us what we want, obviously. So how can we do this, right? How can we just get the sum of every rectangle, it seems like we're doing, right? Well, let me clear this for a second. How do we get the sum from here to here, right? We just do 3 plus 0 plus 1, right? Now, for, let's say we wanted to, let's say we want the sum of the region rooted at 6, right? If we are on row 2, and our prefix sum got reset, let's say it's 0, 5 plus 6, what is the prefix sum of, so we have 11, right? If we do it how we usually do prefix sums, right? 5 plus 6 is 11 right here, right? 11. And 3 plus 0 is 3 up here, right? And the sum of this entire region is what? It is 3 plus 0 plus 5 plus 6, 11 plus 3, 14, right? So it's obvious that in order to get the sum of this square, we had to get the sum of the row column above the bottom right. And we can keep doing this, and we can put 14 right here now, right? And let's go over here, right? 1, 2. This will add, we need 17 now for our total prefix sum. So if we have 1 plus 2 is 3, and we add 14, we add the row column above where we are traversing, then we will have the total region of 1 to 2. We'll have this total region rooted at 2, right? Which is a total sum of 17, and then we can place that there. And then you can see how it generalizes as we iterate through our array. As we grab the above one at our row column we are at the coordinate we are at, right? And then, hold on. Stop screaming. I'm doing something.
Oh, sorry. You kept your phone purposely here?
Yes.
Oh, okay, I didn't know that. All right, bye-bye. Sorry, I don't know you were doing anything.
Always love to. So, sorry about that, guys. But basically, that's how we get the prefix sum, right? But now let's say we just want this sum, right? Well, we have our prefix sum of 17, right? And what would we do? We would subtract off 3 and 0 to get the answer of 14, which is the correct answer. So we would subtract off the above, which is basically the top left of our desired minus 1, and then we would subtract off the left to this, which if there was values to the left, which would be our row 2 right here, column 1 minus 1 right here would be the sum of this entire area. And then we would obviously add back this because it is subtracted off twice. So as you can see, that will be our algorithm. And yeah, that's an edge case though, right? Because this would grab, it would be index out of bounds, right? So what could we do here? We could just add one extra dimension to the row and column and put zeros everywhere. Zeros. So that way, when we do do that process of grabbing the left and grabbing the top and subtracting those off, it'll never be an index out of bounds. So let's code this now. I said we are going to make a new matrix where each coordinate represents from the top left of our matrix to that coordinate's sum as a rectangle. So let's make a sum matrix and let's initialize it. How did I say we're going to initialize it? Oh, look, with the zeros with the extra dimension, right? So let's do 0 times, let's do calls equals length of matrix of 0, rows equals length of matrix, 0 times calls for R in range rows. Let's do, but remember I said we were going to add an extra dimension, so let's add an extra dimension to each. Cool. So this should give us basically this, except with zeros filled everywhere. And then we are going to traverse through this, right? For R in range. Sorry, we're going to traverse through our original matrix, and we're going to update our sum matrix, which is where we'll hold the prefix sum for the entire rectangles. For R in range rows, for C in range calls, I said before we are going to reset our prefix for every row, and then we are going to do prefix plus equals the value at that coordinate. So prefix plus equals matrix of R of C. And then, because we have that now, what will we do? Well, we will say the sum matrix of the corresponding spot, which, because we added an extra dimension, is at R plus 1 of C plus 1 equals the prefix plus above. What is above? Above was the already calculated by this point of R, and then the same column, right? It's just one row back, but same column, which will give us, as you can see right here with the 1417, right? Cool, cool, cool. So once we have that, I believe we're good to go. Now we can implement this sum region function, and I'm just going to offset everything by 1 so we can have clarity with respect to our new matrix. Right, and now we want to calculate this region, right? Or let me back up. Now we want to calculate this whole region, right? And subtract off the left and subtract off the top to get our value of the desired rectangle we want. So let's do that. let me grab the whole entire sum rooted at the bottom right. So entire rectangle equals self.sum matrix of R2 of C2, because this represents our bottom right. And then what did I say? We want to subtract off our top and our above. So our above will be right above our top right, and our top right is at R1 of C2 minus 1. Cool. Or R1 of C2, not C2 minus 1, but R1 minus 1. Cool. And our top, or sorry, our left, what did I say for our left? This is row 2 of our desired rectangle, column 1, and then we want to go back 1 in terms of column. So let's do that. Self.sum matrix of R1, sorry, of R2, that's what I said, and then column 1, sorry, right, is this column 1, and then minus 1. But then what did I say we had to add back? We had to add back this region right here because we subtracted off twice, and it can get generalized even bigger. But what will that be? That'll be the rectangle rooted at R1C1, both of them minus 1. Cool, and then I want to return entire rectangle minus left plus above plus the top left. That should do it. Okay, what happened here? For times calls plus nice. We did it, guys. Have a good day, guys. Thank you for watching. By the way, that was, sorry, to wrap it up, that was O of 1 per sum region call now, and to initialize it was O of n, like O of m times n, where m is rows and n is columns. And space complexity is O of m times n. So O of m plus 1 times m plus 1 if you want to be specific, though. Thank you, guys.